Welcome back to The Explainer. I am so thrilled to have you here today. Listen, if you're building, scaling, or honestly just trying to keep an AI application from completely falling over under pressure, you are in exactly the right place. Today, we're navigating the incredibly complex, high-stakes landscape of 2026 LLM serving engines. We're going to break down exactly what is running inside the modern data center, out on the edge, and right on your local machine to help you make the absolute best architectural choices for your stack.
Okay, let's dive into this, because we really need to shatter a very common illusion right out of the gate. Shipping a large language model is absolutely not just spinning up a model and exposing a basic chat endpoint. I mean, sure, that might have worked for a quick, hacky demo a couple of years ago, but in 2026, no way. The serving engine you pick literally makes or breaks your application. It dictates your multi-tenant behavior, your structured output reliability, and ultimately, let's be real, just how painful your engineering team's 3 a.m. on-call rotation is going to be.
Because these are the brutal, real-world metrics that production teams are actually sweating over. We're talking about maximizing throughput, so pushing as many tokens per second as possible across a ton of concurrent users. Teams are completely obsessed with P50 and P95 latency, and especially that critical time to first token. You're fighting tooth and nail for KV cache efficiency using paged KV and prefix caching. Add in complex concurrency, scheduling, and leveraging heavy quantization like INT4 or FP8 with specialized kernels. Yeah, this is the heavy reality of the modern AI stack.
To make sense of all this, here is our roadmap. We'll start by looking beyond that basic chat endpoint, then compare the big three GPU heavyweights. After that, we'll explore local and edge solutions, gamify your choices with a rapid-fire decision tree, and finally, lock down what actually makes the system production ready.
Starting with Section 1, Beyond the Chat Endpoint. Let's quickly get under the hood at the mechanics driving all these modern systems.
If you look closely at the underlying math and architecture today, you'll spot a really distinct pattern. Almost all modern serving engines are completely converging on the same greatest hits. They all want continuous batching, paged KV, prefix caching, and speculative decoding. It's like the science is largely agreed upon. However, and this is a massive however, while the core concepts are converging, the actual operational experience, the maturity of the software, and the exact hardware they are hyper-optimized for, those differ wildly from engine to engine.
Moving into Section 2, the big three GPU engines. Let's meet the absolute heavy hitters that are dominating data centers right now.
Now, what's really interesting about this slide is how distinctly these three carve up the enterprise market. You've got vLLM acting as this incredibly safe general-purpose default. Then you have SGLang, which aggressively pushes the boundaries of high-performance serving with heavy caching. And finally, TensorRT-LLM, which is just all about raw, unadulterated peak efficiency on NVIDIA hardware. Let's break these down a bit further.
So if you're deploying open-weight LLMs and you just want really strong performance without severe vendor lock-in, vLLM is your very first stop. It has fantastic, broad ecosystem integration. But SGLang, it brings something truly special with its radix attention. If your specific use case involves highly repetitive, chatty system prompts, multi-turn chat history overlap, or really complex tool scaffolding, SGLang's prefill and decode disaggregation can make it shine far brighter for your specific workload.
Now let's look at the quest for ultimate speed. TensorRT-LLM is built for teams going absolutely all in on NVIDIA. It brings these incredible custom kernels and in-flight batching to give you the absolute maximum inference efficiency possible. But, here's the trade-off. You are explicitly choosing an NVIDIA native toolchain. You trade portability for raw power, and if you're managing a massive fleet of these, you're almost certainly going to wrap this in the NVIDIA Triton Inference server to get that standardized platform-level shell around those custom kernels.
Okay, let's take a quick moment of silence here. Face TGI is in maintenance mode as of December 11, 2025. For the longest time, text generation inference, TGI, was the absolute gold standard. It was the giant of the space for Hugging Face deployments. But, in the AI world, you either evolve relentlessly or you enter maintenance mode. The landscape just moves too fast. Even Hugging Face itself now points developers to alternatives like vLLM or SGLang for new inference endpoints.
So the crucial point is this. What exactly do you do if your infra is currently relying on TGI? Well, if you have existing installs, don't panic. Keep it stable. Honestly, it still works fine. But for brand new builds, you would need a remarkably strong, highly specific reason to start a new project on TGI in 2026. The torch has officially been passed.
All right, Section 3, Local, Edge, and Niche. Let's speed things up a bit and look outside those massive data center GPUs at some incredibly specialized engines.
This is essentially the battle of developer accessibility versus rugged utility. Ollama is pure developer luxury. I mean, it offers the absolute fastest local setup, seamless model management, and it even has growing support for multimodal vision models now. It's totally perfect for your laptop or a quick internal team tool. On the flip side, llama.cpp is the undisputed portability king. It is CPU first and designed to run on weird edge boxes, legacy hardware combinations, or frankly, probably your smart fridge if you really tried hard enough. You give up some raw GPU throughput, sure, but you gain the superpower of deploying literally anywhere.
Next up, we have two engines that are completely about aligning your software with your existing corporate investments. OpenVINO is the definitive choice if your infrastructure is highly cost-driven toward Intel CPUs, GPUs, or NPUs. It is tailor-made to squeeze every drop out of that specific hardware. Conversely, DeepSpeed-MII is an inference toolkit designed for high throughput, but its real selling point is ecosystem alignment. If your organization is already fully entrenched in training and operating within the Microsoft DeepSpeed ecosystem, this is just your natural, frictionless serving path. Finally, we have the specialized systems and compiler alternatives. LMDeploy gives you a very C++-heavy, systems-oriented performance runtime powered by its TurboMind engine. But MLC-LLM? It takes a totally fascinating compiler-driven approach. It grants product teams the absolute holy grail of deployment. You compile once, and you run that exact same model natively across desktop Python, JavaScript in a browser, and even mobile environments. It's a real game-changer for cross-platform. Section 4. The 2026 Decision Tree. All right, it's time to gamify this. I'm going to throw some rapid-fire scenarios at you to help you map out exactly which engine fits your current architecture. Ready?
Question 1. You have the budget. You want the absolute, undisputed best performance on NVIDIA GPUs, and you are entirely willing to commit your engineering team to their specific software stack. Where do you go?
Boom, you go straight to TensorRT-LLM, optionally throwing it behind Triton for fleet management. That is your absolute fastest path. Next scenario, your application is highly chatty. You have users hitting the exact same massive system prompts over and over. You've got deep multi-turn conversations, and you need to push your caching limits as hard as mathematically possible. What's the move?
You route that traffic straight to SGLang to take full advantage of Radix attention. And hey, if you just wanted the safest general GPU default, you'd go vLLM. Need it on a MacBook? Ollama. Need it on a random edge device? llama.cpp. The decision tree in 2026 is actually incredibly well-defined once you know your specific constraints.
Which brings us to our final section, production readiness. We've had our fun picking out the engines, but now we need to get serious. Because picking the engine, that is only half the battle.
And this brilliantly illustrates the harsh reality of deploying AI. It really doesn't matter which engine won your decision tree. If you skip this checklist, your system will absolutely fail in production. You must implement request shaping, meaning setting strict max tokens, firm timeouts, and concurrency limits per tenant. You need a dedicated prompt reuse strategy. You absolutely must have streaming and back pressure mechanisms to prevent a total queue collapse when a traffic spike hits. And you need a rock-solid fallback plan, like canarying your rollouts or literally having a secondary, safe engine ready to catch the overflow.
Let's drill down into that observability piece for a second, because these are the exact metrics that will save your skin during a painful 3 a.m. on-call rotation. Basic CPU or server health is nowhere near enough anymore. Your dashboards must explicitly track tokens per second, the time to first token, your P95 tail latency, granular GPU memory usage, and critically, your KV cache hit rate. If you can't see these numbers in real time, you are flying completely blind.
So I want to leave you with this final challenge. Take a hard look at your own stack right now. What is your exact target hardware? Are you running massive H100s, efficient L4s, or just basic CPUs? What is your model class? Are we talking dense models or complex mixtures of experts? And what is your actual real-world traffic pattern? Answer those 3 questions and you have your architecture mapped out for today. But here is the real question to chew on. In a space moving at this blistering pace, will the engine you choose today even exist in 2027? Thanks for joining me on The Explainer, and I absolutely cannot wait to see what you built.